the live session of classes conducted by Wizako. Just wanted to check whether we are live and everything is all right. I'm just going to ask one or two of you whether you can hear me, whether you can see me, whether everything is all right. Quickly, I'll go to the chat window if I can get a response from one of you at least. Just wanted to check whether we are live and everything is all right. I'm just going to ask one or two of you whether you can hear me, whether you can see me, whether everything is all right. Quickly, I'll go to the chat window so we can get a response from one of you at least. Just wanted to check whether we are live and everything is all right. Just going to ask one or two of you whether you can hear me, whether you can see me, whether everything is all right. Quickly, I'll go to the chat window so we can get a response from one of you at least. Just wanted to check whether we are live and everything is all right. Just going to ask one or two of you whether you can see me, whether everything is all right. Quickly, I'll go to the chat window so we can get a response from one of you at least. Thank you, Valluri. Thanks for that confirmation. We'll get started. Today, what we'll be doing is we'll be focusing on descriptive statistics. It's an important topic. About 2 to 3 questions can be expected in the GMAT quant section, both as a problem solving and as a data sufficiency variant. Right. Now, what are we going to do? We're going to be splitting this entire topic into 2 sessions because I think we will not be able to do justice to it in just one session. Today, we'll focus on the following concepts. We'll look at average, which is the easiest among the concepts. And then we'll move on to median, range, and mode. We'll wrap today's sessions with this. In the next edition, in the first week of November, we'll look at standard deviation. Today, the questions that we'll be focusing on will have a problem-solving flavor. We'll focus exclusively on variant, right? So this is how I've broken it. First half of the session, a big chunk of what we'll be focusing on will be on averages. Second half, we'll move on to median, mode, and range. The easier questions that you'll see in the GMAT when it comes to this topic will have just averages. It'll just focus only on average. For example, if you can classify questions on a scale of 1 to 5, the level 1, level 2, level 3 questions will have just averages flavor to them. Once you move to level 4 or level 5, they're going to bring in the other parameters. It'll be a combination of average and median, average and mode, that kind of stuff. Right? With this introduction, let me get started. I'll start sharing the screen as usual, and then we'll get going. After I'm done with a part of the concepts, we'll have a quick chat before we move on to the questions. Can you just check whether the screen share is happening properly, PD, before I start the session? I don't want people. Right, let's get started. I think you should be able to see the screen. What averages is? Average of a it's a number that expresses a central tendency or a typical value for a data set. That is what average is all about. Right? Having known this definition, let's look at how to compute the average. That's the easiest thing. You compute the average by adding the quantities, summing up the quantities, and dividing it by the number of quantities. In terms of a concept, this topic, this is how difficult it gets or how easy it gets. Anything that we'll be doing is going to be based on average is equal to sum of quantities divided by number of quantities. Right? Let's take a very simple example. We have these three numbers, 42, 38, and 16. We need to compute the average of these three numbers. The ages of three people have been mentioned. So sum of these three numbers, find the sum, which is 42 plus 38 divided by 3. 42 plus 38 is an 80 plus 16, which is equal to 96. 96 divided by 3, this is equal to 32. Right? So this is how we compute the average. This 32 essentially tells us if all of these three people had the same age, then what would it have been? That age would have been 32. Note one thing, none of the three ages is a 32, right? So the average need not be a part of your set of data at all. The average tells us, like, if these three people were to go, what is likely to be the age if all of them had the same age? Well, let's tweak this formula a little bit and check out a couple of ways of writing it differently. One, to find the sum, and the second one, to find the number of quantities, right? You cross multiply terms, average into number of quantities, we'll be able to find out the sum. So sum is equal to average into number of quantities. Number of quantities is obtained by swapping these two terms, average and the number of quantities. So number of quantities can be found out as sum divided by average. So this entire topic revolves around these three relations, which essentially is one and the same. Quickly wrap this learning with very simple examples. In one case, we'll find out the average. Second one, we'll find the sum. And in the third one, we'll find the number of quantities. Start with this example. The total score in 5 subjects is 360. What is the average? The average? Average is nothing but sum divided by number. In our case, the sum is equal to 360. The number of subjects is equal to 5. 360 by 5 is equal to 72, right? We're just starting with very elementary examples. We'll wrap it up slowly. As we move, after completing the concepts, we'll just jack up this level of difficulty, right? Till then, let's be on ground zero. Let's start with very elementary questions. Question number 2, we're going to be finding out the total. The average age of 6 students is equal to 14. How do you find the sum? Sum is nothing but average into number. The average is equal to 14. The number of students is equal to 6. So 14 into 6, 84 is the sum of their age. The last one, let's find the number of elements in it. The temperatures for a few days is 252 degrees Celsius. And the average is 36 degrees Celsius. We need to find out for how many of these days have we computed the temperature. How do you find the number? Number is sum divided by average. The sum given to us is 252. The average given to us is equal to 36. 256 divided by 252 divided by 36 is equal to 7. So for 7 days, the average has been computed. Right? So this is the gist of how do you go about an average question. A big chunk of the average questions can be solved in what I would call as a standard framework. I'll go to the extent of stating that close to 90% of the questions will fit into this framework. Any other shortcut that you learn, any other method that you use is good. I'm not like discounting them. The whole thing is the standard framework in most cases will give you an answer in under a minute for average questions. One of the places where you're unlikely to make mistakes. So let's go ahead with this method. Let's understand how this works. Start with an example. The average age of students of class A comprising 20 students is 20 years, right? Class A, number of students is 20, average age is equal to 20 years. For classes A and B taken together, the average age is equal to 16 years. Class B comprises 40 students. What is the average age of students of class B? This is what it is. What is the standard framework? Essentially comprises 3 parameters of quantities. The second one will write the average, and the third one will be computing this sum. We'll have a look at it in the next slide. This is how it's going to look. There's a question given to us. So we'll start with number, average, and we'll compute the sum. Sum is nothing but average into number. Start with class A. Wherever we have information and data, let's write those numbers. Wherever information is not available, always plug in a variable, assign a variable for it. Finally, we'll find out what to do with the variables. Class A, number of students is 20. Their average age is 20, given in the question. So their sum of their ages is going to be 20 into 20, which is equal to 400. Class B, we know the number of students that's given. It comprises 40 students. They have not mentioned the average. That's what we'll have to find out. So let's assign a variable. Let the variable be equal to A. So the sum of the ages in terms of the variable will be average into number, which is A into 40, which is equal to 40A. The two classes taken together, 20 students in class A plus together makes it 60 students. Their average for both the classes taken together. Sum of their ages is going to be average into number, which is 16 into 60, which is equal to 960. Now to compute A, all that we are going to do is the sum of the ages of the two classes, 960, is nothing but sum of the ages of students of class A plus class B. So 400, which is the sum of the ages of students of class A, plus 40A, which is sum of the ages of students of class B. This should be equal to 960, which is sum of the ages of students of both the classes taken together. So 40A is equal to 560, or A is equal to 560 divided by 40, which is equal to 14. This is what we wanted to compute. What is the average age of students of class A, class B? That is equal to 14 years. Use the standard framework. For most questions, this will help you get the answer without making a mistake. It will probably take you about a minute or a minute and 10 seconds. That's all it will take for most of these questions. Now, this is the same thing. You captured it in a printed form. 400, sum of the ages of students of class A. 40A in terms of the variable, sum of the ages of students of class B. Together their ages is equal to 960. So basically going to say 960 is equal to 400 plus 40A. We computed A to be equal to 14 years, right? So done, dusted. Let's move on. Let's look at the concept of weighted average. In a way, in the last example, we used it, but let's take a deeper look into it. Start with a very simple example. Mike weighs 40 kgs and Mary weighs 50 kgs. What is their average weight? Right? This is the simplest question that you could get. Their average weight is sum of their weights divided by 2. 40 plus 50 by 2, which is equal to 45. Now let's tweak these two numbers with a slightly different set of information. Let's say the average weight of boys in a class is 40 kg and that of girls in the class is 50 kg. Now it's no longer one Mike and one Mary. There are some number of boys in the class and some number of girls in the class. We need to find out what is the average weight of. Temptation is to go with a 45. Most of you would have by now figured that's probably not the right answer. Let's look at a couple of scenarios and then see what is needed. Right? Let's find out what if the class has 5 girls and 5 boys. 5 girls, the average weight of the girls is equal to 50. So for the sum of the weights of the girls is equal to 5 girls into their average weight, which makes it 5 into 50 equal to 250. Let's look at the sum of the weight of the boys in that class. How many boys are there? 5 boys. Their average weight is equal to 40. So sum of the weights is going to be equal to 200. So what is the sum of the weights of boys and girls taken together? That's going to be equal to 450. How many of them are there? 5 boys and 5 girls. That adds up to 10. So total weight of the entire class is 450. The number of students is 10. So their average weight is equal to 450 by 10, which is equal to 45, which is the same as what we got. So the average is going to be the simple average, provided that there are 5 girls and 5 boys. Let's tweak this assumption. Let's check out what if it is a little different. What if we had lesser number of boys? Had only 2 boys in the class and 8 girls. Let's find out the weight of the girls. Sum of the weight of the girls, there are 8 girls. Their average weight is equal to 50. So sum of their weights is going to be equal to 8 into 50, which is equal to 400. The weight of the boys, there are 2 boys. Their average weight is equal to 40. So 2 into 40, this is equal to 80. Sum of the weight of the entire class is 480. Number of students totally is equal to 10. So their average weight is going to be equal to 480 by 10, which is equal to 48. So it is not the 45, it is 45, which is equal to 48. So if the number of boys had been 2 and girls had been 8, 45 would have been an incorrect answer. Let's just swap this number and see what happens. If you had 8 boys and 2 girls, 8 boys, sum of the weight of the boys is going to be equal to 8 into 40, which is equal to 320. Sum of the weight of the girls, there are 2 girls and their average weight is equal to 50. That makes it 100. So sum of the weight for the entire class is going to be 420 for 10 students. So their average 20 by 10, which is equal to 42 kgs. So one thing, we know that the average weight is not 40 as it was in this particular example. It could have been a 45, could have been a 42, could have been a 48. It could be any number which is in between 40 and 50. So one thing that is very clear is to arrive at the average, we need more information. What information do we need? We need to know the number of boys and the number of girls in the class. In simple average, we assumed the weightages to be the same. There is one Mary and one Mike. Whereas when it comes to the weighted average, the weightages need not be same. More importantly, keep track of like this when it comes to a data sufficiency question. Sets. Can you find out the combined average for both those sets? Unless you know the individual numbers or the ratio of the numbers, you cannot. In a data sufficiency question, this carries much more weight than in a problem solving question. Right? Let's move on. So how do we go about finding this weighted average? One, present you with the formula. So it's a good way to go about it. The weighted average is nothing but average of the first element into the weightage of it. Weightage in this case is number of boys plus average of the second set into the weightage of it divided by sum of the weightages. Right? So A1 into W1 plus A2 into W2 divided by W1 plus W2. Let's take a simple example. The average weight of boys of the class 40, girls is 50. I'm just giving this additional information that we did not have. The class has 20 boys and 30 girls. What will be their average weight is what we're trying to find out. Let's plug it into this formula. Is equal to 40, which is A1. Number of, that's a weightage, that's a W1. Plus average weight of equal to 50. And the number of girls is equal to 30. That is your W2. W1, nothing but 20 plus 30. So quickly the value for this is 800 plus 1500, which is equal to 2300 by 50. So 46 is the weighted average of the students of this class. Now, the simple average would have been a 45, whereas the weighted average that we have got is a 46. We'd just like to quickly recall this question with the numbers that we used. When we had boys and girls as 5 and 5, the average that we got for the entire class was 45. When we had 2 boys and 8 girls, the average worked out to a 48. When we swapped it to 8 boys and 2 girls, the average came down to a 40. When the numbers are equal, simple average value. The weightage, whoever has more number, in this case, girls are more in number. So the average is going to tend towards the weight of the girls. The weight of the girls, that's why the average went to the right-hand side of 45. In the third instance, we had more boys than girls. Therefore, the average is going to be pulled towards the average of weight of the boys. The average weight of the boys was 40. So it was not a 45. It came down lesser than 45. So one, you have the simple average. If you're anyway computing the weighted average, to know whether it is going to fall on the right of the simple average or left of the simple average, all you have to take a look at is who has got more weightage. The larger weightage element is what is going to pull the average towards it. Right? Just move a little forward. We used a formula to compute it. We can plug it into the standard framework, which is the first example that we did. We'll quickly wrap it once more with this to highlight the fact that you don't need a formula for weighted average. Our standard framework will just well do. It will help you get the answer, whether it is weighted average, whether it's simple average, it really does not matter. Right? Let's plug this entire data into our standard framework. Standard framework has number, has average, and it has got sum. Let's check out how it works in this case. Number of boys is 20. Their average weight is 40. So sum of their weight is going to be 20 into 40, which is equal to 800. Comes to girls, 30 girls are there, and their average weight is equal to 50. So 30 into 50, their sum of their weights is going to be equal to 1500. The entire class together will have 50 students, 20 plus 30. Sum of their weights is 800 plus 1500, which is equal to 2300. What is their average weight? 2300, which is the sum of their weight, divided by 50, which is equal to 46. So this is our standard framework. It works very well with the standard framework. You don't need anything more. One important thing that I wanted to at this point, you could know the number of boys and number of girls as 20 and 30. Conversely, the question could have said the boys and girls ratio in the class is 2:3. You would have got exactly the same answer in terms of the weighted average. Quickly run through that exercise here. 2 into 40 would have been an 80. 3 into 50, just multiply the ratio. Don't worry about the numbers, which is equal to 150. So sum of their weights would be 230. The sum of the ratios in this case is a 5. 230 by 5 will give you the same answer, which is 46. So don't number, the weightage can very well be given to you in terms of a ratio. Right? So we have done simple averages, we have done weighted average. Now let's move on to solving certain questions. These questions will help us get a good grasp of it. Right? We close this slide back and open the next one. Bear with me for a minute. We're going to be solving 3 questions which focus on averages. All 3. Let's look at how they go. First one, the average salary of a graduating class of 30 students is 8420 per month. And that of another class comprising 20 students is 8438 per month. What we need to find out is the average monthly salary of students of the 2 classes taken together. Right? Set it up in the standard framework, take a minute, try and solve it, and then come back. We'll discuss this. Right? This question is interesting mainly because of the numbers that it carries. The questions that you solved till now, we illustrated it with very simple numbers. Here the numbers are getting a little more interesting. Right? We'll come back to discussing that in a minute. I'll in the meantime take a quick peek at the if there is anything that I need to know about it, and then come back to the screen. Right, let's take a look at this question. I'm going to set up the standard framework to solve this. Right, number, average, sum is nothing but number into average. Class 1 has 30 students. Their average salary is $8420. So some of their salary is 30 into 8420. Right? Nothing fancy here, just straightforward. A lot of these questions, you don't need to know any fancy stuff. Class 2, 20 students, 8438 is their average salary. So some of their salaries is equal to 20 into 8438. Gist of what we need to find out is the average of the 2 classes. These 2 numbers, 30 into 8420 plus 20 into 8438. And the number of students is equal to 50. The average that we are trying to compute is basically this value. The pain point in this entire thing is computing this 30 into 8420 plus 20 into 8438. And GMAT does not permit a calculator for the quant section. So we need to figure a way of doing it. Those of you who went about actually finding these numbers, pat yourself. If it is a large number, do it, don't mind. But the only thing is, walk you through a method which will probably make this entire computation a little easier. We'll take it to the next screen, this part of the calculation. Right? This is what a little differently. This 30 into 8420, I'm going to retain it as it is, plus 20 into 8438. I'll split it as an 8420 plus an 18. So I can make the calculations work a lot better than computing the entire value by themselves. So this essentially, if I expand the second term, it's going to be a 30 into 8420 plus 20 into 8420 plus 20 into 18. This is what we have, 50. So what do these 2 terms add up to? 30 into 8420 plus 20 into 8420 is 50 into 8420 plus 20 into 18 is a 360 divided by 50. This calculation is like second standard calculation, right? 50 into 8420 by 50. The 50 cancels with 50 for the first part to leave us with an 8420. The second part of the calculation, which is 360 by 50. 350 by 50 is a 7. The left of the 10. 10 by 50 is a 0.2. So this is equal to 7.2. So the final answer is 8420 plus 84 plus 7.2, which is 8427.2. Right? I'll write it again. This is 8427.2. So this made the entire calculation a lot simpler. Quick takeaway at this point. So if you're trying to find out the weighted average of large numbers, so how do you go about it? One very systematic way to go about it is basically split the second term, the larger term, in terms of the smaller term plus something. So you'll be able to take this entire component out and you need to do the calculation only for this part of it. Right? So the first takeaway from this, we'll quickly wrap this entire thing in a printed form. Right? So this is the calculation we want to do. We have written this 8438 as 8420 plus 18. That basically translates to 50 into 8420 plus 20 into 18 plus 50. This part of the calculation is going to leave you with 8420 as the answer. The second part is going to be a 7.2. So final answer is 8427.2. Now, this is the one which I would actually want you to do, right? We'll take it one step further from the earlier edition, right? What we're going to do is, you don't need to necessarily do so much calculation. Even this is a little painful. Whenever you'll have to find out the weighted average of two large numbers, in the standard framework as you're setting it up, subtract from the average of the smaller component, the average of the smaller component. We'll do that in the next slide and I'll show it to you so you'll know what I'm talking about. Right? I'm going to subtract 8420 from both these values and set up the standard framework in this slide. Number, there are 30 students in this class. 8420 is their average. 8420 is a smaller number. I'm subtracting it. So the average salary for the first class actually is a 0. So what is the sum? Sum is 30 into 0, which is equal to a 0. So we didn't do any calculation at all. Second class again, I'm going to subtract this 8420, the smaller value from it. So the average works out to an 18 right now. So what is the sum of their salaries? 20 into 18. This is equal to 360. So what is the sum of the salaries for both the classes taken together? This new value after subtracting 8420 is nothing but 0 plus 360, which is 360. Number of students is 50. 360 divided by 50 is equal to 7.2. Now we got the intermediate average to be equal to a 7.2, which is your 360 divided by 50. Now to compute the final average, the 8420 that we subtracted from it will add back to get an answer, which is 8427.2. I'm going to use this exercise that we have done to basically do a key inference from it. We'll start with this very simple example. Let's say set S comprises 5 numbers, 1, 2, 3, 4, and 5. I'm going to add a 5 to each of these elements. So what will the set look? Okay, we'll compute the average for it. We'll just skip this step. The average of these 5 numbers is a 3, which is 3 plus 3, 6 plus 4, 10 plus 5, 15 by. One quick thing that you can use as a time-saving thing. If numbers end up being in an arithmetic progression, the middle number is the average. 1, 2, 3, 4, 5 is in an arithmetic progression. So the average is the middle number, which is a 3. As I had mentioned, let's add a 5 to each of these terms, and let's call that a set T. So set T, the elements are going to be 6, 7, 8, 9, 10. These 5 numbers are also in an AP, so their average is going to be the middle number, which is equal to 8. So average set T is equal to 8. Average of set S was a 3. Average of set T is an 8. How did we arrive at set T? We added 5 to each of the elements in set S. The same value K to each. Average of the new set is going to be K more than the average of the old set. The average for the old set was 3. We added 5 to each element in S. So the average for set T is going to be 5 more than the average of S, which is going to be equal to an 8. So this works for addition. Subtraction is nothing but adding a negative number. So what works for subtraction? Will it work for multiplication? Let's take a quick look. Right? So set S will retain it as such. So our average is going to be a 3. Let's do a very simple multiplication. Let's multiply each element by a 2. So we'll call it a set U. Set U 6, 8, 10. These numbers are also in an AP. The middle number is going to be the average, which is equal to 6. So the average of elements of set U is a 6. How did we arrive at U? By multiplying 2 to each element of set S. The average of elements of set S was a 3. U was obtained by multiplying each element by a 2. The average of U is twice the average of S. So if I multiply each element in a set by a K, the average also gets multiplied by the same K. What is division? Division is nothing but if I multiply a number by k and divide a number by k, dividing a number by k is nothing but multiplying the number by 1 by k. Subtraction exactly work the same way. Multiplication and division work exactly the same way. So key inference from this is essentially if a constant k is added or subtracted to each term of the data set, the average will also get added or subtracted by the same k. If I multiply or divide each element in the set by a constant k, then the average also gets multiplied by a k or by a 1 by k as the case might be. Right? So keep this. This will come in handy when you realize that you're talking about two sets in this multiplied by a 5 or every element has got added by a 7. Right? So keep this perspective. Let's move on to the second question. The average of 5 positive integers is 40. This is a question that I like a lot. I use this as a part of the information session that we use in the GMAT. The largest value among the 5 is 44. What is the minimum value for the smallest of these 5 numbers? Right? What kind of numbers is there? Don't make any unwarranted assumption. Right? Take a minute. We'll come back to it. I'll quickly take a look at the chat screen. There's something where I can add, answer things. I'll come back to this in a minute. But I think we've taken a minute. Let's see how to go about it. Right. Let's just understand what information is given. Let's assign variables to these 5 numbers. Let them be A, B, C, D, E. And for want of a better one, let's make A to be the smallest of these 5 numbers. Our objective is to find the least value possible for A. That is the objective that we have. Right. What information do we have? The question mentions that the average of these 5 positive integers is equal to 40. So sum of these 5 numbers is going to be 40 into 5, which is equal to 200. So A plus B plus C plus D plus E is equal to a 200. Our objective is to find the minimum value of the smallest number, which in our case is A. The constraint given to us is the largest value 44, all of these 5 positive integers. Right. So trying to minimize plus B plus C plus D plus E is equal to 200. If A has to be minimized, it is quite evident that we need to maximize the remaining numbers. We need to maximize B, we need to maximize C, D, and E. All 4 of those numbers will have to be maximized. Start with a B. How high can the value of B be? The largest among these 5 numbers can only take a value of 44. The largest value that is seen among these 5 numbers is a 44. So let's assign a 44 to B. Let's move on to C now. How high can the value of C be? Did any of you go with a 43? It looks like 43 is a number that you should go with. But let's read what this question mentions about these 5 numbers. It says these are 5 positive integers. It did not make a mention about these numbers being distinct. So numbers can very well be same. So the largest value permitted for these 5 numbers can be a 44. So can C be a 44. How high can C be, right? The larger the value that C and B and D and E take, the lower the value for A it's going to be, right? So C can very well be a 44 because these numbers need not be distinct. B can be equal to C, which can be equal to D, and can be equal to E. All 4 of these numbers can be a 44. The trap in this question is most of us might have thought about going with a 44, 43, 42, and 41, and would have arrived at an answer which is not the least possible value for A. And believe me, GMAT would have that answer as one of the answer choices. So you need to walk when it comes to number properties questions and questions in descriptive statistics. Check out whether the numbers are integers. They need not even be integers. Check out whether they are distinct. Don't make any unwarranted assumptions. Right? So now all these 4 numbers are of 44. So sum of these four numbers is going to be 4 into 44, which is 176. That leaves us with a balance for A. So how low can A be? A is going to be equal to 200 minus 176, which is a 24. So the value of A cannot be anything lesser than 24 if their average is 40 and the largest value among them is a 44. Okay. The key takeaway from this question, numbers are not distinct. Do not make the assumption that they are distinct unless the question states so. Move on to the third question. This is an interesting question too. Aaron was asked to calculate the arithmetic mean of 10 positive integers. Now start making note of these, right? They said that these numbers are positive integers. Are they distinct? Not mentioned. So these can very well be same numbers, right? Each of which had 2 digits. Added 10 2-digit numbers. By mistake, he interchanged the 2 digits, say A and B, in one of these 10 numbers, AB. So the 10 numbers, 9 he wrote them perfectly. One of the numbers, he wrote the AB as a BA. So his total is going to be different, therefore his average is going to be different. His arithmetic mean was 2.7 more than what it should have been. What we need to find out is what is B minus A. To just get started, first jot down the key data that's given to us. The compute the average. Aaron was asked to compute the average of 10 2-digit positive integers. 9 of them were written right. One number AB was written incorrectly as a BA. So the number, let's say, was a 27. This guy wrote it as a 72. So that's a mistake he made. The average computed by him was 2.7 more than the correct one. I'm going to assign some variables. Let the sum of the 9 numbers that he wrote correctly be yes. So that's right. That's right in Aaron's case, and that is right as how it should have been. So there's nothing that needs to be done there. Let the correct average of all 10 numbers be an A. The average at Aaron therefore be A plus 2.7. Based on this, Aaron's average A would have been sum of the 9 numbers that he wrote right plus BA, because no, this Aaron's average is at A plus 2.7. Excuse me for this mistake. A plus 2.7 is equal to S plus BA divided by 10. The A is equal to S plus AB. This is what the original number is. This divided by 10. So written both these equations. Now what we're going to do is let's cross multiply. The first equation is going to be S plus BA is equal to 10 times of A plus 2.7, which is 10A plus 27. Let's call this as equation 1. The second equation, let's cross multiply this A and 10 to get the right hand side as a 10A, and the left hand side is going to be S plus AB. Let's call this as equation 2. Subtract equation 2 from equation 1. S gets cancelled with S, 10A gets cancelled with 10A. So what we have is BA minus is equal to 27. Right? We have done this using equations. Just take a minute. Let's just understand. Aaron had 10 numbers. Also had 10. The incorrect one that Aaron had also had 10. The average of the first set 0.7. The sum for the first set is going to be therefore, the sum for the second set is 10A plus 27. So if there are 10 numbers in 2 sets and their difference in average is equal to 2.7, the difference in their sum is going to be the number of elements, which is 10, into the difference between their averages, which is equal to 2.7. So this 27 is something that we should have arrived at without writing any of these equations. Why did this difference become at 27? Why was the difference in the sum 27? Was it because of the sum of these 9 numbers? Definitely not. Those 9 numbers were spot on. So the difference is primarily because this guy wrote an AB as a BA. So difference between BA and AB is what should have contributed to this 27. So you should probably, after having read the question, come to this step, right? With practice, when you're exam ready, you should not have written anything that I wrote here. You should have come to this point directly. Now, is BA minus AB what we need to find out? We're actually trying to find out B minus A. To take this example, the number is at 27. They're not asking us for 72 minus 27. They're asking us to find out 7 minus 2. So how do we go about it? Let's take that further. Let's go with this 27 as an example itself. 27, we need to find 7 minus 2. That's our objective. So I need to extract 27. Right now, the 2 carries a value of 20. So it's assigned place weights to it. So 27 is nothing but 2 into 10 plus 7 into 1. If I do that for both our BA and AB, this is what we'll have. The equation that we have is a BA minus AB is equal to a 27. Let's assign place weight explicitly. So it's going to be a 10B plus A minus 10A plus B. This is equal to 27. 10B minus B is a 9B. A minus 10A is equal to 9A. So 9B minus 9A is equal to 27. Take the 9 common outside. So what we'll have is equal to 27. Or B minus A, which is what we need to find out, is 27 by 9, which is equal to 3. So this is the answer. The question is done, but the discussion and the learning is not over. Let's have a quick look at it. Forget what this right hand side. It could be a 27, 72, 45. Let's keep that later on. That way the question is going to provide you as a data. Let's look at the left hand side. A BA minus AB, a 2-digit number, and the difference between that number and its transposed version, where its digits are interchanged, will always be a 9B minus 9A, because BA minus AB, we wrote it in this form, which translated to a 9B minus 9A, which is nothing but 9 times of B minus A. So if you have a number, let's say 18 and 81, what will be the difference between these two numbers? Take it as a 9, and the difference between the digits, which is 8 minus 1, 9 into 7 is equal to 63. So net, keep this in mind. The difference between a 2-digit number and its digits interchanged will always be 9 times the difference between the 2 digits. So we'll come back to solving our question. So we should have come up with this BA minus AB is equal to 27 as step 1, having read the question. The moment you've seen this, you know that BA minus AB is always going to be equal to 9 times of B minus A. So this is equal to 27. So B minus A is equal to 3. So ideally, when you're exam ready, this entire question should have taken you 25 seconds and not more than that. What if we are talking about sum of these two 2-digit numbers, AB and BA? This is going to be a 10B plus A plus a 10A plus B is what we'll have. 10B plus B is 11B. A plus 10A is 11A. So this is going to be 11 times of B plus A. So sum of a 2-digit number and its transposed version. Let's check that out. 18 plus 81, we know is a 99, which is nothing but 11 times of 8 plus 1, which is equal to 11 to 9 or 99. So difference is 9 times of difference between 10 times of sum of the digits. So key takeaway from this question, difference between AB and BA is always 9 times the difference between the digits. Sum of AB and BA is 11 times of A plus B. So next time you come across any question that talks about interchanging digits, just go with this and wrap it up in about 30-40 seconds. Right? So this basically brings to an end the first of the parameters, which is averages. Let's quickly do a 2-minute recap of this before we move further. Right? So this is what we have. I'm going to stop the screen share. We'll have a quick. Right. Average is computed as some key formula with which we are working. Weighted average as a concept talks about you need to remember that weightages are going to be different. You can't assume weightages to be the same, especially when it comes to data sufficiency questions. Watch out for this carefully. Then we derived a standard framework which essentially had it this way: number, average. Sum is nothing but number into average. You cannot add, subtract average. What you can add, subtract is the sum and the number. Whenever you don't have any data, assign a variable for it into the standard framework. Most questions in average can be solved using the standard framework. Lastly, I'd like to leave you with a quick discussion where we'll try and 10 people and the average sum of money with them is equal to $1,000. So 11th person joins in. This person joins in with money with him as $1,000. What will happen to the average? The 11th person who walked in with as much money as what the rest of them on an average had. So average is going to remain unchanged. Right? Let's quickly check with our standard framework. 10 people, average is 1,000. So sum of the money with them will be 10,000. The 11th person comes in, adds 1,000 to it. So total money will become 11,000 for how many? 11 of them. So the average stays intact at 1,000. So if you add any number of elements whose value is will stay intact. No, this 11th person who walked in did not walk in with 1,000. Let's say he walked in with $1,110. He has brought in more money than the average. See, obviously the average has to increase. What has he done? He has brought in $110 more than he should have brought to maintain the average in $10. It's as if he's dividing it among the 11 of them, including himself. So the average is going to go up by 110 by 10, which is equal to 110 by 11, which is equal to $10. So the new average, if the 11th person had brought in $1,110, will be $1,010. What if he came up with lesser money? If this person walked in with, let's say, $890 with him, he had brought in $110 less than what he should have got to maintain the average at 1,000. So he's brought $110 lesser, and that is essentially saying that he's going to take that money away. So 110 by 11 will reduce the average by 10. So if lesser than the average joins the group, the average is going to go down. If more than the average joins the group, the average is going to go. The question that we did, where we added and subtracted values, that question where we had 8420, 8438. If each element in a set is added or subtracted by a k, the average also gets added or subtracted by the same k. If each element in the set is multiplied by a k or is divided by a k, the average also shows the same in it. Right? So we'll move on to the next parameters. We'll quickly wrap up the concept behind all three of them in one set of slides. And the questions that we're going to be doing in round 2 will be much more difficult than what we have done in the first one, which dealt only with averages. Right? We'll look at range, then we'll move on to median, and then finally mode, and then wrap questions which use a combination of this data. Right? I'll start sharing this screen. Just give me a minute. Right, let's start with range as the next parameter that we'll be discussing. Definition of range is the difference between the largest and the smallest value in a data set. Take the simple example, 7, 42, 38, 123, and 16. The largest number among them is 123. The smallest number is a 7. 123 minus 7, 116 is the range for this set of numbers. Right? What is the application of range? What does range mean? What does it measure? Range basically measures the statistical dispersion in a set of data. What does that mean? They're essentially saying how far apart are the data elements in the data, are these elements in the data set. Take a simple example to understand this. Right? Here's a set of 5 numbers, 3, 7, 11, 15, and 19. As you read numbers, get a feel for the numbers. These numbers are in an arithmetic progression where the common difference is a 4. So their average is going to be equal to 11. We need to compute the average. Average is equal to 11. What is the range? Pick the largest number, which is a 19. This number 3. 19 minus 3 is equal to 16. Let's look at one more set of data. Take these 5 numbers, 9, 10, 11, 12, 13. Consecutive numbers will always be in an AP. The middle number is average for this set too. We'll have to find out the average. Average for this set of numbers is 11. Range in this case, the largest number is 13. Smallest number is 9. Range is equal to 4. The average for both these sets has been the same number, which is 11. The range for the first set is 16. The range for the second set is a 4. If you look at it, these numbers are, this gap between them is larger. They're far more dispersed than the number. Larger range essentially means that the numbers have a higher dispersion. A smaller range essentially means that numbers have a smaller or lesser dispersion in them. Right? So between the two sets, the average could be same, but the dispersion could be different. Let's move on to the second parameter, which is median. The definition measure of a central tendency, pretty much similar to average. It's another way of measuring the central tendency of a set of data. What is the median for a set of odd numbers? If you have odd number of observations, the middle number, write those numbers in an ascending order. The middle value is going to be the median. What if you have even number of observations? Write them in an ascending order, no change there. Find the middle 2 numbers. Find the simple average of that. That is going to be the median. For a large data set, what is it going to be? It is a 50th percentile value. We talk about what is the median income for a country. We are talking, if you arrange the income of everyone in the country to the one who's earning the most, the middle value, the 50th percentile, is what the median is. The median tells us that half the observations in our data set are less than or equal to the median, and the remaining half are more than or equal to the median. Very useful, especially when you read school websites which talk about median GMAT score, right? If you are an Asian test taker, more often than not, we are in the applicant pool, which a lot of people, international students, apply from. So you have to look at the median score saying that there are half the number of students who have more than that. Let's say you read the median score to be a 710. So this is the school for which you need to have a high GMAT score. If you're not from an Asian applicant pool, then a 710 tells you that half of them have got less than 710. So I have a good chance of making it to the school. So basically, whether you're in a more competitive applicant pool or a less competitive, as in more people apply from a set, makes that difference. Right? So keep this perspective when you're looking at median scores when schools report them in their website. Right? Let's move on further. Let's take a few examples to understand this entire process. We have these numbers 1, 2, 3, 4, and 5. 5 numbers, odd number of elements. Write them in an ascending order: 7, 16, 38, 42, and 123. The middle number is 38. That's a median. Very straightforward. Let's move on to even number of numbers: 7, 38, 123, 74, 16. 6 numbers. Let's write them in ascending order: 7, 16, 74, and 123. 2 numbers are the third and the fourth numbers: 38, 42. And 42 is 38 plus 42 by 2. This set of numbers. So odd number of numbers, after right ascending order. Even number of numbers, the process, pick the middle two terms, find their simple average. That gives you the answer. So move on to understand a little more about it. Let's use this example itself. If an equal number of observations are added to either side of the median remains unchanged. Let's go with this example. The median is a 38. I'm going to add, let's say, a 4 here, and let's say a 125 here. Will the median change? We have 7 numbers right now. The fourth number is going to be the median, which is the 38. So that's what this observation is all about. Conversely, if I added more numbers to one side of the median than the other, right? We've added 1 to each side. Let me add a couple of more here. Let me add a 2 here, and let me add a 3 here. Now, how many terms do we have? We started with 5. We added 2 more, so it made it 7. Now, adding these 2, we have a total of 9 elements with us. The middle number is going to be the fifth one. Which is the middle number? 1, 2, 3, 4. 16 happens to be the median. We added more elements to the left-hand side of the median. Therefore, the median shifted to the left. If you add more elements to the right-hand side of the median, it will shift to the right. Keep these perspectives. Again, will help you running through a calculation. Right? Have this perspective about whether the median is going to shift to the left or is going to shift to the right. Let's look at mode, definition of mode. The most frequently occurring number that's found in a set of observation is the mode. It is not the number of times it appears, it's a number that appears with the highest frequency. Right? Here's an example to help us understand. In this set, 4, 5, 4, 1, 7, 4. 4 is the term, is the element that appears with the highest frequency for this set of data. Now, let's look at this. Not just 4 that appears thrice. 4 appears thrice. So does 1. So what is the mode for this set of numbers? This is a bimodal data set. It's got 2 modes. 1 is a mode, 4 is a mode. It's not the number of times that they appear, that's a frequency. The number that appears with the highest frequency is the mode. So you can have data sets which have more than 1 mode. If it is 2, it's bimodal. If it is 3, it's trimodal. If it is more than that, we'll call it as multimodal data set. Let's look at this example. This is 4, 5, 4, 5, 1, and 1. All the numbers appear twice and with the highest frequency in this data set. So what is going to be the mode for it? We'll say the mode is equal to 4, 5, and 1. What if elements occur exactly once? If elements occur exactly once, then we'll say that this set of data has no mode. Keep that in mind. Right? So then in a question, you read that this data set has got no mode. Then what we are talking about is none of the elements occurs more than once. Right? When no number occurs more than once, we call it as there is no mode. But if it occurs equal number of times, then we'll call it multimodal. In this case, it's all three numbers are appearing, so we'll call it as trimodal. What is a mode measure? Mode measures essentially the most popular data set. For example, in this 1, 2, 3, 4, 4, 5. Let's say these are the companies in thousands of dollars of 6 graduates from a school. What is likely to be the most likely salary? $4,000 is what we have. That's the answer to this, right? That is what a mode measures. Key takeaway from this: what do each of these things measure? Range measures dispersion of the data set. Median measures the central tendency. It tells you what the 50th percentile person in the data is getting, right? And finally, mode measures the most popular element in the data set. What we'll do is we'll quickly look at 4 interesting questions to solve in this, and then wrap the session with that. Just give me a minute before I open that slide back. I'll read the question, give you 30-40 seconds. I'm sure a lot of you are part of the chat window would have got the question earlier, and then we'll get cracking solving them. The range of weight of men in a team is 12 kgs, and that of women in the team is 10 kgs. What is the range of the weight of the team if the lightest man in the team is 3 kgs lighter than the heaviest woman in the team? Take about 30 seconds. We'll set about solving this. Right, we'll get started with this question. I think we'll be running out of time sooner than later. So what we'll do is we'll solve 2 of the questions, and I'll leave 2 for you to crack at your time. I'll add the solution to them as part of the web page where you landed to come up with the session, and it'll also be part of the YouTube, right? We'll get started with this, solve this and the next one, and then we'll have solutions for the remaining 2 available to you later on. The range of men in a team is equal to 12 kgs. So the heaviest man minus the lightest man is equal to 12 kgs. The range of the women in the team is 10 kgs. So the heaviest woman minus the lightest woman in the team is 10 kgs. We need to find the range for the entire team. The link between the men and women is given here. The lightest man in the team is 3 kgs lighter than the heaviest woman. So let's try and write these weights in ascending order. Here is the heaviest woman, and then there is the lightest man. The difference in their weights is equal to 3 kgs. The heaviest woman and the lightest woman, because the range is equal to 10, that is going to be equal to, the lightest woman is going to be to the left of the lightest man, because the lightest man is only 3 kgs lighter than the heaviest woman, whereas the lightest woman is 10 kgs lighter than the heaviest woman. Now let's look at what happened in the case of men. The heaviest man is equal to 12 kgs more than the lightest man. The heaviest woman is only 3 kgs more than the lightest man, whereas the heaviest man is 12 kgs more than the lightest man. So the heaviest man is going to fall to the right of the heaviest woman. So therefore, what we have is lightest woman, lightest man, heaviest woman, and heaviest man. This is what we have. Now, going forward, you can solve this algebraically. What we are going to do is we're going to plug in some values. Basically, assume a number for something like this. Let the lightest woman be 40 kgs. Let her weight be 40 kgs. So from this, we can quickly compute the weight of the heaviest woman. 10 kgs heavier than this. So she's going to weigh 50 kgs. We know that the lightest man is 3 kgs lighter than the heaviest woman. So lightest man is going to weigh 47. The heaviest man is 12 more than the weight of the lightest man. So 47 plus 12, that makes it as 59. We need the range for the team, which is the heaviest man minus the lightest woman. 59 minus 40 is equal to 19. This is the quickest way to solve this question. You can solve it algebraically. Plug in numbers where you can. That's a quicker and surer way to get the answer than framing algebraic equations. Let's move to the next one. Consider 11 distinct integers. This is a beautiful question. We'll solve this The question mentions these are distinct integers. Are they positive integers? The question does not mention it. So there is a possibility that they could be negative. So keep these things in mind as you read the question. Whose median is 90 and range is 60. Median for these 5 smallest integers is 65. We need to find out the maximum range for the 5 largest integers. We'll solve it in about 30 seconds. Give it a shot. Those of you who have already got this question on the chat window, come up with the answer for it. We'll discuss it in 30 seconds. Let's get started. Let's pictorially represent the data given to us. Let's say the numbers are x1, x2 up to x11. And let x1 be the smallest of these numbers, x11 be the largest of these numbers, and the ascending order be x1, x2, x3. It's easy to process in our mind. Right? Whose median is given to be equal to 90. The middle number is going to be the median, which is nothing but x6. So x6 is equal to 90. The range of these numbers is a 60. Essentially is x11 minus x1 is equal to 60. The question mentions that 5 smallest integers are going to be x1 to x5. Their median is a 65. For these first 5 numbers, the median is x3, which is equal to 65. So we have plotted all the information given to us pictorially. So look at what we need to find out. The objective is to find out the maximum range for the 5 largest numbers. x1 to x11. Which are the 5 largest numbers? x7 to x11 are the 5 largest numbers. We are not asked to find out the range. We've been asked to find out the maximum possible range. So what do we have to do? We need to find out how big can the gap between x7 and x11 be. How do we achieve that? Push x11 as much to the right as possible and pull x11 as much to the left as possible. x7 should go as much as possible. x11 should go as much to the right as possible. So what are we trying to do? We're trying to find out the maximum possible value for x11. That's when it will go to its rightmost. And the minimum possible value for x7, which is when it will go to its leftmost. Let's start with minimizing x7. That's the easier of the two things to do. These are distinct integers. x6 is a 90. The question mentions that. So x7, how low can it be? It cannot be anything less than 91. So this part is done and dusted. Finding the minimum value for x7 is the easiest one. The more interesting value for x11. Look at this. There is an umbilical cord that ties x1 and x11. And this cord is 60 units in length. So x11 is always going to be 60 more than x1. So if x1 is 1000, x11 will be 1000 plus 60. If x1 is a 1, x11 is going to be 1 plus 60. So if I push x1 as much to the right as possible, if I maximize x1, then 60 more than that is how high the value of x11 can be. Now, how do we maximize x1? That's where this data comes of use. We've been told that x3 is a 65. Less than x3. And if it is distinct, the maximum possible value for x2 is a 64. Extending the same possible value for x1 is a 63. Cannot be anything more than 63. Then x11, which is 60 more than that, cannot be anything more than 123. So maximum possible value for x11 is equal to 123. We computed the minimum value for x7 as a 91. Here we have come about finding out the maximum value for x11 to be equal to 123. The last step is finding the difference between these two to find out the maximum range for these 5 largest integers. The maximum value of x11 is 1. Value of x7 is a 91. So maximum range possible is equal to 123 minus 91, which is equal to 32. These questions are not calculation intensive. They are very analysis intensive. Right? Many times the questions that are actually on the tougher end of the spectrum expect you to do more analysis than calculation. Right? So do these 2 questions. These are available as part of the website. Right? Take a look at it. These questions have also been posted as part of the chat window by Muthu. Right? Try them at home. I'll have these solutions posted in the video by Monday or Tuesday. Right? This question, I'm going to quickly run through it. the other question. So these two are there. Thanks for being a part of this entire session. Just wanted to leave you with a little thing. The next session is scheduled for November 3rd, 2017 at 10 p.m. We're still going to be delving on this topic, statistics and average, part 2. What will we be looking at there? We'll be looking at standard deviation and we'll be looking at DS. SD and DS is the focus on that day. Right? See you at that session. But before we wind up, 3 things. 1, subscribe to the YouTube channel. You'll be notified of all new videos that we keep adding. Been trying to add videos at a pace which is much faster than what it is right now. Hopefully in the next month, I should have had more videos than what I've added in the past. Second one, we have an Android app where the entire online course is available for you and you can download videos and watch it at your time and pace. Couple of topics that are free. Descriptive statistics is free. There are a few tests that are free. Try them. This helps you keep pace of it. Where do you download the app from? app.wizako.com. It will redirect you to the Play Store from which you can. Lastly, send me your feedback to baskar@wizako.com. What you liked about it, what you would like to have discussed in this, and we'll use it for the next session. Right? Thanks, guys. Thanks for being a part of this session. Before we finally close this entire thing, I'll take a look at the chat window. There is something that I can answer. I'll definitely do that. Thanks, guys. See you next week. Not next week, on the 3rd of November. Right? In the version for December, I've requested Shweta to walk us through critical reasoning. So the month after that is critical reasoning.